This is Zain Ul Abdin. I'm a PhD student working in LTI laboratory at University of Pikahi. My thesis supervisor is Professor Ahmad Rashid, and the title of my presentation is A Solar PVT Living Laboratory as a Cyber Physical System. What is SolLab? It is an open solar living laboratory for research and development of solar energy technologies, and the platform is planned on the roof of the LTI laboratory at University of Pikahi. The living lab will be used for real-time experimentation, and beside this we will have our own PVT system. The lab is a part of Solarize project co-funded by European Interreg 2Cs program. What is a photovoltaic thermal system? A PVT system provides heat and electricity by combining photovoltaic module and thermal module into one integrated module. The thermal module extracts the heat and PV module generates electricity using photovoltaic cells. The heat transfer medium, which runs below the photovoltaic module, plays a vital role in heat extraction. This medium can be water, air, or some other fluid. There are two common types of PVT systems. One is air-based PVT system and other is water-based PVT system. In air-based PVT system, we have an air channel which takes cold air from one end of the panel and provides hot air from other end of the panel. These air-based PVT systems are used for heating, ventilation, and air conditioning. The second type is water-based PVT systems, and they are the most common used panels for domestic heating purposes. The system consists of water tubes in which water is injected from one end of the panel and hot water is collected from other end of the panel. For the modeling of a PVT system, we have two mathematical models. The thermal model is built on energy conservation principle and electrical model is built using Shockley diode equation. A nonlinear thermal model, which can be written as a function of state x, control input u, and uncontrolled inputs w. The state x is the temperature of each layer, and we can have 4 to 7 states depending on the model. The control input, which is mass flow rate, and the uncontrolled inputs, which are solar radiation, wind speed, and ambient temperature. The output y, which is the outlet temperature of the fluid, and for electrical model, we have electrical power as output. The next section is optimization and control. To measure the uncontrolled inputs, a weather station is installed, and sensors are placed at different points to measure current, voltage, temperature of fluid, and temperature of the panels. Physical and design parameters are optimized using optimization tool. To design a new PVT, and thermal and electrical outputs are maximized. It is necessary to have a control to guarantee the desired temperature depending on the application. The installation consists of two units which are completely independent and both consist of 4 panels in series each. Each panel will be monitored individually and we will use lab-built Internet of Things module for communication. The electric power is used for charging tricycle, for smart lighting, and for other purposes. To store thermal energy, we have a water tank and we have batteries for electric energy storage. A CAN bus is used to allow devices to communicate, and sensors are used as measurement devices. Thank you for your attention.